The second and last example we'll do, you can see this function is a little more complicated. So it is the square root of x times the sine of x. So we want to estimate the definite integral of that function between pi over 2 and pi with 4 partitions. Alright, so the lower limit is pi over 2, the upper limit is pi. Each trapezoid is pi over 8 units wide. Right. This function, I wouldn't really expect you to graph it without some reference to a calculator or something else like this. But this is what the graph looks like. All right. And with each trapezoid being pi over 8 units wide, we're going to have an area between here and here. We're going to break it up into 4 equal partitions, each pi over 8 wide. So they might look like this. So my sketch looks like that. Notice it's not all that pretty. It doesn't have to be. I just need to be able to visualize what's going on there. And I probably want to label these 5 pi over 8, 3 pi over 4, and 7 pi over 8. And that's pi there. So each one of these is pi over 8 wide. Right. So my initial take here is exactly the same as the simpler function. I'm writing it in terms of function notation. I still have 4 partitions. Each one's pi over 8. I have to think about how the heights, or really the B1 and B2 are defined for that trapezoid. So this B1 of this trapezoid right here is the function height at pi over 2. That's f of pi over 2. This one is the function height at 5 pi over 8. That's f of 5 pi over 8. So I have pi over 8 times f of pi over 2 plus f of 5 pi over 8, all divided by 2. And then I move along, first trapezoid, second, third, and fourth trapezoid. All right, this can be and you can see this is a pretty tedious process. Okay, we're going to make it a little bit less tedious by thinking first before we jump on using our calculator. Notice that there's a pi over 8 in each term. That'll happen when the partitions are uniform, but you have to be careful because the partitions are not always going to be uniform, so make sure that they are before you do this. So we can factor a pi over 8 out, and they're all divided by 2, so I can factor a 1/2 out. So what that allows me to do is it allows me to say, okay, well, I have pi over 16 times f of pi over 2 plus f of 5 pi over 8 plus f of 5 pi over 8 plus f of 3 pi over 4 plus f of 3 pi over 4 plus f of 7 pi over 8 plus f of 7 pi over 8 plus f of pi. Right? So I can write it that way and make it a little bit easier to calculate. Now let's talk about how we can calculate this. All right? We can do that bit by bit, so we can do these two as we have them written up here, or we can just do these all together. It doesn't really matter one way or the other. All right? So if we do it just all together, we can go put our function in y1. So we have the square root of x times the sine of x and now when I try to evaluate these functions, I can use the calculator and do function notation. So I want the calculator to calculate f of pi over 2 for me. So to do that, I can do alpha f4 y1 of pi over 2. plus f of 5 pi over 8. So I go alpha f4 y1 of 5 pi over 8, and so on. Okay, when I do that, this is the calculator's notation for f of pi over 2 plus f of 5 pi over 8. I can continue that along. All right. Plus f of 5 pi over 8 plus, now notice here that if I look carefully at this, I notice that here I just did y1 of 5 pi over 8 plus y1 of 5 pi over 8. In each case here, when I look at this, I notice that there's 2 f of 5 pi over 8s, there's 2 f of 3 pi over 4s, there's 2 f of 7 pi over 8s. So I can shorten up the amount of things I have to type by making this 2 times f of 3 pi over 4 plus 2 times f of 7 pi over 8. Now there's just one f of pi. So I can do that. Then I can multiply by pi and divide by 16. So that answer times pi divided by 16 gives me my numerical estimate based on trapezoidal approximation of the area underneath square root of x times sine of x between x equals pi over 2 and x equals pi. So I got 1.4299. I always want to keep 4 decimal places, and I have here the calculator estimate is 1.4579, and let's see where we get that from. If I go alpha f2 function derivative from pi over 2 to pi of the function y1, and we're integrating with respect to x. So I get 1.4586, 1.45786. So I can either truncate that and just call it 1.4578, or I can round it. The 6 makes that 8 round to a 9, so 1.4579. Either one of those answers would be perfectly fine, but I ask that you keep 4 decimal places. And notice when we did this, I didn't really add these up individually in the example as I did it, but you can. So in this, and as it's written here, I just did f of pi over 2 plus f of 5 pi over 8. I got this. Then I did f of 5 pi over 8 plus f of 3 pi over 4, and I got this, and so on. If you do that and you have intermediate steps, be sure not to round off in your intermediate steps. Keep all the decimal places for your intermediate steps. Only round off after you get your final answer. Do not round the intermediate steps or you will get it wrong. Your answer has to be exactly, precisely correct to at least 3 decimal places, and in this class we're going to always do 4.